at all. That's right. That's right. So no questions about the homework. We're A-okay on nth roots? Yeah? All right, let's move on then. We're going to add and subtract radicals today and multiply. So we'll say operations with radicals. All right. It's so awkward. What are these for? Note cards with letters on them. Well, I don't want to knock them over if they're in a quarter, so I'm going to do this. All right. So operations with radicals, we're going to start with addition and subtraction. Y'all need a second to get your stuff out? Adding and subtracting radicals. Here's the thing. They have to be what we call like radicals. So you know how we add like terms or combine like terms? Same kind of thing with radicals. We combine like radicals. So what makes it a like radical? It has to have the same root. What do I mean by root? Somebody asked me yesterday, what does root mean? That's right. Right outside that radical, what we're calling the nth root, this is the root. That's what I mean whenever I say root. All right. So it's got to have the same root, and it's got to have the same number under the radical. Good. So let me show you some examples of some like radicals. Which ones of those are like radicals? The second and fourth person? Second and third. This one and this one are like radicals. The others are not, because I'm looking for two things. I'm looking for the root and the number under the radical. When those are the same, that's what makes them like radicals, okay? And those are the ones that I can combine. So if I asked you what's the cubed root of 7 plus 2 times the cubed root of 7, we would combine these just like we would if it was x plus 2x. Meaning I just combine the coefficients. Get off. Get off it. How do I get it off? Oh. Bruh, I'm trying. Combine the coefficients. So this will become what? 3 cubed root of 7. Because there's an imaginary 1 in front. Okay. Now, they're not going to look like this when you get them. Of course, it's going to be harder than that, right? We're going to have to simplify them. You want to go get some water? Oh, well, that's reassuring. Okay, so we'll have to simplify them and get them to look like the like radicals that they are before we can combine them. So let me show you an example. We'll start easy. 3 times the square root of 27 minus 2 times the square root of 12. Simplify that expression. Can you combine? Yes, you have to. Can you combine those like they are? Why? They got the same root, though. The number under it's not the same. That's exactly right. So what I want to do is I want to try to simplify them before I do anything else. So how could I did actually bring a few. That's really bad. I got like the funny one. What are you gonna be? No, it was so funny. I would never take one. I texted her. I stopped drinking. My they normally use like the lemonade or something in it. But she had to use a different one because they ran out of the lemonade, whatever it was. So she used a tropical thing, but it was really good. I like it. I was about to email you. Like, you should have. I haven't yet. It's the normally those drinks last me all day. I'll drink them and then I'll add ice to them and drink them and add ice to them. It'll last me all day. That one I have. It's gone in like 2 hours. It must have made it really sweet when she subbed that flavor out. Wow. I'll have to try that one. All right, everybody got a calculator now? Break the 20, boys. Break the 27 down. What and what? 9 and 3, so I got 3 times the square root of 9 times the square root of 3. Square root of 9 is what? Red. It's 3, so I got 3 times 3, which is 9 times the square root of 3. How did the other one break down? 4 and 3. Remember, I'm multiplying by 2 here. So I get 2 times 2, which is 4 times the square root of 3. Now, are they like radicals? Yes, the root's the same. The number under the root is the same, so I can combine the coefficients. What's 9 minus 4? 5. So I get 5 times the square root of 3. Yes? Shall we make it harder?
No. No, no, no.
We have to.
No. No, you don't.
We must. I appreciate your politeness. I'll do this one and I'll save the hard one for just a minute. You with me over there? Do it, yes. This arrangement would not work with you guys. Wait, okay, so look at the first one. Now, notice that I'm powers of 4 this time, right? Okay, so the last, right. I might not be able to combine them all, so let's take that off. Okay, so look at the first one. Can it simplify? Yeah. What can I divide 48 by? 16. 16 and what? 16 and 3. What is the fourth root of 16? 2, right? So I've got 7 times 2, which is 14 times the fourth root of 3. Okay. This one is 2 fourth root of 3. How about this last one? It's a third root, y'all are right, so I know I'm not going to be able to combine it, but could I simplify it? Yes. What can I divide it by? 27 and what? 8 and 9, yeah. 8 and 9. This is going to be 2. This one just stays. So I've got 6 times the cubed root of 9. And now I combine what I can. And if you can't, you just leave it, right? So I can't do anything with that one. And several of you noticed that right away. I can't do anything with that one because the root is different. I know, that's good. Yeah. All right, so what do I get for the first two? 12 times the 4th root of 3, and then I have to keep this one. We haven't multiplied yet. Yeah. Is it, all right, let me show you one with some variables in it to make sure you can do the variable ones. Mark, set, go. Mark, set, go. I'm coming to see what you got. I can walk around this time.
Yeah.
Maybe I'll put my groups back in there so I can walk around.
No.
No. What'd you get, Caleb?
What I get what? Oh, it's 4.
Oh my gosh. Rat, what are you doing on your computer now? Because you weren't doing math before. You took out of 98. 49 and 2, which would be 7 times the square root of 2. We all agree? All right, so I got 7 square root of 2, but I also need to look at these variables. Remember, this is an imaginary 2, so 2 goes into 4 how many times? Twice, with nothing left over. 2 goes into 2 once with nothing left over, and that 2 is still under that radical. 4, that's exactly right. Notice my like terms with my variables include all of that, so the coefficients that I'm combining are 7 and -3, which would give me 4, and then everything else stays on there. Say that again? No. All right. I'm fixing to move him right up here with me. No. Do you do this to your other teachers, or you just save it all for me? Oh my God. Let's multiply the radical. As long as the roots are the same. Yep. Multiply under that root. No, I don't. And then we're going to make sure we simplify. Yes. And you can multiply what's outside too. Let me show you what I'm talking about. Okay. Okay.
Yeah.
Is everybody gonna be here tomorrow? Who's not gonna be here? The day before spring break. Math? We'll probably have a quiz tomorrow. Y'all won't be here for real. I think it's gonna do this all day. All right. If I am multiplying, I'm multiplying these, and so I could do these several different ways. I could simplify each one first and then multiply and then simplify again. I prefer just to multiply as they sit and then simplify at the end. But whatever you want to do, these are the same roots, so I can combine them, okay? So I'm going to put them, here's the way I think about it. Since they're the same root, I'm just going to put them under the same radical multiplying. So what's 54 times 5? Is it? No, it's not. Is it? Yeah, it is. You did that in your head, Armando. Yeah, you did. That's good. M to the what? M to the what? M to the what? M to the what? What's m to the 8th times m to the 4th? M to the 12th. Now how do I simplify this? Break it up. 270 can break down into what and what? 27 and 10. So if I've got 27 and 10, what's the cube root of 27? 3. So I've got 3. 10 is left over. And then 3 goes into 12 how many times? 4. How many are left? There it is. That's easy, right? Adding and subtracting is definitely harder than multiplying, in my opinion, unless you get something right. All day. Shut up. What is wrong with y'all? Multiply. Trying to make your life harder. It's great fun. I'm having fun. You're not having fun?
No.
Thank you, Hannah. Thank you. I appreciate your support. All right. Got it?
No.
Rhett's talking like he's got it. I'm watching you, Rhett. I'm watching you. That's what I got. Is that what y'all got? Huh?
6K minus 6K.
Okay, under what? Oh, there is. There is. Sorry. Thank you. Can I combine those? No, I can't. They're not like terms, so I cannot combine them. What you think?